Hi girls, we're going to have a look today at the equation of a line, which last lesson we didn't actually call it the equation of a line, we called it the rule. We called it the rule that described the relationship. Here's the lines that we created last lesson. These are the lines based on the number of fingers and the number of students. If you remember, in our first line, the rule, I'm using y's and x's, not f's and s this time. The rule was y equals 10x. So the number of fingers in the room is now represented by y, is equal to 10 times the number of students in the room. We also introduced that rule there relates to this line here. The purple rule goes with the purple line. We also introduced another scenario where I was a mad science teacher and I had a jar of fingers that sat on the desk in my room or in the cupboard at all times. So there was always these 5 extra fingers in the room. So that changed our rule from y equals 10x to y equals 10x plus 5, because even when there were 0 students in the room, our x-axis is the number of students, even when there were 0 students in the room, there were always these 5 fingers. So we had to add 5 to every 10x. So we got these two rules, y equals 10x and y equals 10x plus 5. And if we notice here, these two rules have a couple of similarities. First is that they both produce a straight line. The second is that the straight lines have the same slope, don't they? We call another name for the slope is the gradient. And that slope is expressed by this number here, 10, but we'll go into that a bit later. And the other thing that we notice is that this number here, the 5, or in this case here, the 0, describes where the line crosses the y-axis. So if I add a 5, then it moves up the y-axis 5 points, and it crosses at the point 0, 5 there. So every straight line can be expressed like this. All I need is an understanding of the gradient or slope of the line, and I need to know where the line crosses the y-axis. And I can use this information, the gradient and the y-intercept, to describe the line like this: y equals mx plus b. So just sit with that concept for a moment. We're going to go back and pull apart this idea of gradient now. So let's have a think about the slope of a line. And to do that, sorry, I've gone ahead of myself. How do you find the m and the b in the equation of the straight line? In other words, how do you find the gradient and the y-intercept? Well, the y-intercept is easy, as we saw in the last slide. We just see where the line crosses the y-axis. But how do we define this concept of gradient? Well, the way mathematicians do it is they calculate the rise over the run. So this line here has a certain slope. I can express that slope or gradient by drawing a little triangle underneath it, finding out how much does y change. In other words, how much does it go up? Or in other words, what is the rise? How much does it go up when it goes across a certain amount? So the rise, or the change in the y, over the run, the change in the x's. Another way of thinking about the gradient: how far up the y-axis does the line go for every change of 1 unit in the x-axis? Okay, don't worry if that's still coming to you. We're going to have a look at Line Rider just for a bit of fun. I don't know if any of you have seen Line Rider. I've set up in Line Rider two hills for my little guy to go down. If you're not familiar with Line Rider, it's just a game where you set up a track and your person goes down the track and you try not to kill the person, which I haven't been successful. So I've set up two lines, and you can see that they have different slopes, can't you? This line here is a steeper slope, and this line here is not so steep. Let's start with the first guy, the first line, the steep slope. See what happens to my guy. He goes down, dies at the end because it's a little bit too much of a difference at the end. So that's the steep one, and now let's try our guy on the not so steep one. He goes down. Oh, he didn't like the big drop from the point to the... So either way they've died, but we've thought about the gradient of the two lines. Okay, let's go back to our slide now. Here they are. I've got my really steep slope and my not so steep slope. You can see, if I wanted to say to someone, this line's steeper than that line, but the person said to me, okay, but how much steeper? How could I work out how much steeper that line is than that line? I'll have to work out some way of measuring the steepness of the line. Hang on a sec. Okay, sorry, I've just flipped the image around so that we can look at it that way, and I'll explain why I did that later. Okay, how can we measure the steepness of this line and the steepness of that line in such a way that I can tell people, alright, this is this gradient and this is that gradient? Well, if you look at it, an easy way to do it would be to say, okay, they both cover the same amount of ground horizontally, don't they? But where one goes up that far, the other one goes up much further. So if I can measure the difference, if I can measure these rises and compare them, then I'll be able to measure the gradient of that slope. So say I measure this distance here. Oops. If I measure this distance here and measure that distance there, then I'll be able to see that this one goes a higher distance upwards than this one. Yeah? Do we agree about that? Okay, that's cool, but sometimes my slope goes a further way across. So I might have a line that goes like this. So it's the same distance up as the steepest one, but it's a different distance across. So I need to somehow take into account the distance across that it goes as well as the distance up that it goes. So that's where we come up with this formula of rise over run. Let's go back to that very nice drawing there. I need to measure how far up it goes and how far across it goes. So I look at the rise, but I also divide it then by how far across it's gone. And that gives me an indication of how steep it is. Going back to our slidey guys, I can see, say that I measured that up and it gave me a gradient of 2, and that had a gradient of 3. Well, this new one that I've measured here has the same gradient as this original one, so I would expect that to have a gradient of 2 as well. Oh, Nice. Okay, I'm not 100% sure that you're comfortable with the idea of gradient, but what I want you to do is go and have a try. If you look at exercise 4D and just start working through 1 and see how far you get. So 1 has questions about gradient. Let's go and look at a few.